Hello and welcome to this class. Today we are going to discuss an important concept in economics, marginal. Suppose that ABC knows its cost function C of x, and it has tentatively planned to produce 2,000 units this year. We would like to determine the additional cost per unit if ABC increased production slightly. Would it, for example, be less than the additional revenue per unit? If so, it would make good economic sense to increase production. If the cost function is the one shown in this figure, we are asking for the value of delta C over delta x when delta x is 1. But we expect that this will be very close to the value of the limit of delta C over delta x when x is 2,000. This limit is called the marginal cost. We mathematicians recognize it as the derivative of C with respect to x. In a similar way, we define marginal price as the derivative P with respect to x, marginal revenue as the derivative of R with respect to x, and the marginal profit as derivative P with respect to x. Because economics tends to be a study of discrete phenomena, your economics professor may define marginal cost at x as the cost of producing one additional unit, that is, as C of x plus 1 minus C of x. In mathematical model, this number will be very close in value to the derivative. And since the latter is a principal concept in calculus, we choose to take it as the definition of marginal cost. Similar statements hold for marginal revenue and marginal profit. We now illustrate how to solve wide variety of economic problems. Now let's see one example. Suppose that the cost function C of x is equal to 8,300 plus 3.25x plus 40 times cube root of x dollars. The question is to find the average cost per unit and the marginal cost, and then evaluate them when x is 1,000. Jordanson, would you like to solve this problem?
Yes, the average cost is C of x over x, which equals 8,300 plus 3.25x plus 40x cube root of x over x. The marginal cost is dc over dx, which equals 3.25 plus 40 over 3 times x to the 2 over 3 power. At x equals 1,000, these have the values 11.95 and 3.38. Respectively, this means that it costs, on the average, $11.95 per unit to produce the first 1,000 units. To produce one additional unit beyond 1,000 costs only about $3.38.
All right, very good, Jordanson. In this problem, you found the difference of the average cost per unit and the marginal cost. Next, we are going to determine when shall we produce the maximum total profit. Jack, would you like to read the problem for the class?
Okay, in manufacturing and selling X units of a certain commodity, the price function P and the cost function C are given by P of X equals 5 minus 0.002 times x, and c of x equals 3 plus 1.1x. Find expressions for the marginal revenue, marginal cost, and the marginal profit. Determine the function level that will produce the maximum total profit.
Very good job. Thank you, Jack. Let's solve the problem together. So first, the revenue function is R of x is equal to the product of x and p. So in this problem, it's equal to 5x minus 0.002x squared. And the profit function is equal to the difference of the revenue function and the cost function. So it is this expression. Thus, we have the following derivatives. The marginal revenue is equal to the derivative of R with respect to x, and we can find that it's equal to 5 minus 0.004. And the marginal cost is the derivative of the cost with respect to x, and it's easy to find that it's 1.1. Then the marginal profit is the difference of the marginal revenue minus the marginal cost. To maximize profit, we set the derivative of p with respect to x, set it equal to 0, and solve this. And this gives x is 975 as the only critical point to consider. It does provide a maximum, as may be checked by the first derivative test. So the maximum profit is a p at the point 975, and it's about $2,000. Note that at the point x is 975, both the marginal revenue and the marginal cost are 1.1. In general, a company should expect to be at a maximum profit level when the cost of producing an additional unit equals the revenue from that unit. Today, we solved some problems. And we know calculus is one of the most widely used branches of mathematics in economics. In business, calculus is mainly used for optimization. This includes maximizing profits, minimizing costs, and maximizing or minimizing production. Also, calculus can be used to calculate the rate of change in the cost or the marginal revenue for an interest-bearing account. We discussed some applications of calculus in economy in this class. Hope you enjoy it. I'm looking forward to seeing you in next class. Thank you.